All right, if you're gearing up for your CompTIA A+ exam, you know that storage is a huge part of it. But we're not just talking about how many terabytes you can get. We're talking about a much bigger problem. What happens when things go wrong? Because let's be real, every single hard drive will fail. It's not a matter of if, but when.
I mean, just look at this thing. It's a marvel of engineering, sure, but it's also incredibly delicate. When this fails, everything on it, your operating system, your precious family photos, your critical work files, it could all just disappear forever. This is one of the fundamental problems that IT pros have to solve. So how do we guard against this? How do we protect our data? Well, the answer is a technology called RAID.
Okay, so what is this magic? RAID stands for Redundant Array of Independent Disks. I know it's a bit of a mouthful, but the idea is actually pretty simple. You take a bunch of separate, individual hard drives, and you use smart technology to make them work together as one team. And that team has two main goals: redundancy, which is just a fancy way of saying keeping your data safe from drive failures, and performance improvement, which means making your computer read and write data way faster. The different types of RAID, which we call levels, are all about finding the perfect balance between those two things: safety and speed.
So let's kick things off with the absolute speed demon of the bunch, RAID 0. If you need pure, blazing fast performance, and you don't care about anything else, this is the one for you.
So, how does RAID 0 get so fast? Well, it uses a really cool technique called striping. Imagine you have a big file to save. Instead of writing that whole file to just one drive, RAID 0 chops it up into little pieces and writes those pieces across all the drives in the group at the exact same time. It's like going from a one-lane road to a four-lane superhighway. Everything just moves so much faster.
So you get this incredible performance with a minimum of 2 drives. But what's the catch? Oh, and it is a huge catch. RAID 0 has absolutely zero fault tolerance. None. If even one of those drives fails, the entire thing is toast. All your data is gone. Think of it like a puzzle. Each drive only has a piece of the picture. If you lose one piece, you can never put the whole puzzle back together again. That's why you only use RAID 0 for stuff that isn't critical, like a temporary scratch disk for video editing, where speed is literally the only thing that matters. And here is your big CompTIA A+ exam tip. When you're reading a question and it's screaming speed, performance, fast as possible, and it doesn't say a single word about data safety or redundancy, your brain should immediately lock on to RAID 0. Just remember this: RAID 0 means zero redundancy. Simple as.
All right, now let's do a complete 180. We've seen the risky speedster. Now let's meet its polar opposite, the super safe, super dependable bodyguard. Let's talk about RAID 1. The whole strategy for RAID 1 is a technique called mirroring, and it is exactly as simple as it sounds. Every single piece of data you write to the first drive is instantly, automatically, and perfectly copied to the second drive. You have a perfect real-time clone, an exact mirror image of your data at all times.
All you need is 2 drives, and with that you get excellent fault tolerance. If one of those drives suddenly dies, the system doesn't even skip a beat. It just keeps on running using that perfect mirror copy, and your data is completely safe. This makes it perfect for the operating system drive in a server, or even your home PC if you have data you absolutely cannot afford to lose. Now the big trade-off here is storage space. You lose 50% of your total capacity. So if you go out and buy 2 1TB drives for a RAID 1 setup, you only get 1 TB of space you can actually use. The other drive is just your insurance policy.
Okay, so we've seen all speed and no safety, and all safety with so-so speed. But what if you need a mix of both? You know, a happy medium that's also efficient with storage space. Well, that's where RAID 5 and 6 come into play, and they do it using a really clever idea called parity. RAID 5 is super popular in the business world because it's a fantastic middle ground. Just like RAID 0, it stripes data across multiple drives so you get really good read speeds. But here's the clever part. It also adds in a special piece of data called parity. You can think of parity as a kind of mathematical clue. This parity information gets spread out across all the drives. Now, if one of the drives fails, the system can look at the data on the good drives, look at that parity clue, and it can mathematically rebuild every single piece of missing data onto a brand new drive. Pretty neat, right? You need at least 3 drives to make this work.
So if RAID 5 is so great, why do we need RAID 6? Well, this slide breaks it down perfectly. RAID 5 is tough, but it can only survive 1 drive failure at a time. RAID 6, which needs at least 4 drives, is like the bigger, tougher sibling. It calculates 2 sets of that parity information. And what does that mean for you? It means it can survive 2 drives failing at the same time and still keep all your data safe. This is for when data availability is absolutely critical.
And here is another golden nugget for your exam. Listen closely.
If you see a question and the scenario explicitly says it must survive 2 simultaneous drive failures, stop right there. Don't overthink it. It's not RAID 5, it's not RAID 10. The answer they are looking for is RAID 6. They love to test if you know that specific difference.
So, what if you want it all? What if you demand the insane speed of RAID 0 times and the rock-solid redundancy of RAID 1? Can you have your cake and eat it too? Yes, you can. Let's talk about RAID 10. Now, you'll hear people call it RAID 10, but it's much more helpful to think of it as RAID 1 plus 0, because that's literally what it is. It's a combination or a nest of 2 different RAID levels. Here's how it's built. First, you take pairs of drives and you mirror them using RAID 1. So now you have these little super safe mirrored sets. Then you take those protected sets and you stripe data across them using RAID 0. The end result is a stripe of mirrors, which gives you the safety of mirroring and the speed of striping all in one package.
Now for this setup, you need a minimum of 4 drives, and it always has to be in even numbers so you can make those pairs. The performance? Absolutely fantastic for both reading and writing. The fault tolerance is also really high. You can lose 1 drive from each of your mirrored pairs and your data is still safe. This makes it perfect for things like high-performance databases where speed and safety are both top priority. But all this goodness comes at a price. Just like RAID 1, you lose 50% of your storage capacity, which can make RAID 10 a pretty expensive option.
All right, I know that was a ton of information. So let's take a breath and pull it all together into one simple, easy-to-read cheat sheet that you can use to study for that A+ exam.
This table right here is your key to success. Just burn this into your brain. RAID 0 is all about speed but offers 0 safety. RAID 1 is all about safety, but you sacrifice half your storage. RAID 5 gives you a nice balance of performance, safety, and efficiency and can handle 1 drive failure. RAID 6 levels up that safety to survive 2 drive failures. And finally, RAID 10 gives you the best of both speed and safety, but it's going to cost you. Understanding the main focus and the key trade-off for each of these is what the exam is all about.
So, to wrap things up, I'll leave you with a classic exam-style question. Let's say you're setting up a server. You need a good balance of performance, it has to be able to survive a single drive failure, and you want to be as efficient as possible with your storage space. Which RAID level ticks all of those boxes? Think about what we've covered today, and you'll know the answer. Thanks for watching, and good luck with your studies.